All right, the microphone is on this time. Good morning. So today we're going to be going over or trying to implement 3D terrain generation in our engine here. But before we get into that, I've got a couple of quick public service announcements. The first one is you can turn off all those really annoying notifications in Windows in the notification settings. I don't know if they're all going to be turned off, but I can't believe I didn't look at this 10 years ago. Those are the things that pop up in the corner in this little dock thing. And the other thing is, I can't remember right now. So let's just get into it. So I kind of got an idea for what I want to do. And it's going to be not this, but something like 3D noise terrain. I'll just have a look at some images here. We can get a bit of an idea. So I want to do interior terrain, not exterior. So like a cave, for example. Maybe I'll just write cave in here. Well, actually kind of like this. Yeah, cave generation. I guess sort of like this. I mean, that looks really hard. It's really hard to tell what's going on in that image. I guess you can't really see cave generation that easily, but if you imagine a cave in something like Minecraft or Deep Rock Galactic is a big inspiration, something like that. So we're going to try to implement something like this, but the first step I think is going to be I want to just render some points. So basically right now, it's been really cool. We got models loaded, we got some sunlight, and we got some lights and all that kind of stuff. That's all well and good. But something I was thinking about was, well, what if we made a game that didn't even have outside and then outside, and then we didn't have to worry about a lot of stuff. We could use different rendering techniques. So what I'm going to do today is just remove this model. I'm going to load a point cloud up in here, see if we can render some points. So a point cloud is just well, it's what it kind of sounds like. It's a 3D volumetric object of points. And the points, I think I'm going to represent density first. So we'll do a traditional marching cubes style 3D terrain. So look at marching cubes 3D. We can find something. Sebastian Lag has a really nice video on it. I've implemented this a couple of times. And in fact, I think I've shown it on stream a couple of times. Oh, that's interesting. We got an error. Device lost. Device lost. That's a bit weird. How would the device get lost? I'm not sure. I'll have to look at that at some point. But essentially, something like this. So you get these nice sloped edges here. And it's sort of low poly look, which is what I'm sort of interested in, I think. We'll see. But yeah, first things first is these are actually made of a bunch of 3D points. And each point, you can see in these little images here, has a density value usually. So it could be between 0 and 1, between -1 and 1, or it could be between some arbitrary numbers. And then, let me just make this image a bit bigger. Actually, open image. Oh, you can't do that anymore, hey? Oh, you can. Open image, new tab. There we go. So it's a little bit pixelated, but it's fine for our purposes. So I think if you look at this one on the left here, these bottom 4 points are going to have, let's say the density value is between -1 and 1, and then the intersection is at 0. So these bottom ones will be -1, and the top ones will be 1, and that will make a flat plane in between those points. And you can kind of see, I think that's what they're highlighting with these. So you can say these are either on the inside or on the outside. But in this cube here, If you've got 8 points and 2 of them outside, then you're going to make these 2 triangles in the corners. It's the same for all these configurations. So there's actually only, I think there's 16 configurations, and then they're all flipped and rotated, or mirrored. And that gives you up to 256, I believe. So yeah, first things first, I just want to look at the points in 3D space. So I know that Vulkan has a fill mode, not fill mode, it's called something else. It's called topology. It's called topology. So if we look at the topology of any of our pipelines here, we're usually using triangle list, or I think we've also got a triangle strip. Yep, so this one. So essentially what I want to do first is, I guess, make a new pipeline. I'm going to base it off of the, I guess I'll base it off of the default pipeline, because we're going to need a uniform buffer to send the points in. I guess they could be in a vertex buffer. Need to think about it. I think I'll just use a uniform buffer for now, until I get a better grasp of what's going on. So I'll just grab this code here. I'm gonna go down and stop selecting everything. Stop selecting everything, thank you. And then we're gonna go down, and I've got so many pipelines now. I even got a debug UI pipeline, which I haven't finished implementing yet. There we go. Okay. Descriptor sets, yep, that looks good. Okay, this is unaligned. Okay, so this is going to be our point cloud pipeline. Sure, why not? So we're just going to have one uniform buffer, and it's going to be available in the... Actually, we don't need a uniform buffer. Should have just used the vertex buffer. Okay. So depth visualization, no. Debug pipeline. This is sort of more similar to what we want. I could just delete it from here. That's fine. All right. Where were we? We were here. No. Here we go. Okay, good. All right, so point cloud pipeline. I'm just going to delete these descriptors. Are we going to need a uniform buffer? We might. For the density values. But then actually we might not need any buffers, because, I mean, we will need one for density values. So let's just leave that. All right, so we say vertex. Actually, we don't want to do it in these shaders. We want to do it in a compute shader. Okay. All right, first steps first. Let me just write this out. So I want to build our way up to compute shader marching cubes. I actually already have an implementation, but it's from a little while ago, and I want to revisit it to make sure that I understand everything, and I think we can actually change it to make it a bit better. But anyway, let's have a look. So we want something like visualize points, and then next step would be, I mean, the next step is like draw the whole owl, but I don't want to go straight to that. I guess get one, draw one configuration, and then draw multiple, or actually like implement marching cubes. Now the thing I want to try after this is, actually I'm not sure if we're even going to get to this point. I want to try signed distance fields. And if we can do signed distance field marching cubes, is that even a thing? I don't see why it wouldn't be. A signed distance field. Actually, I think they're called sign distance function. Or are they field? SDF graphics, distance. Well, there's distance functions. So I was already looking at this website actually. Sign distance field. Sign distance field. Okay, it is sign distance field. Okay. So we're going to have a 3D set of points in space. And even if that point has no value, or rather has no mesh, it should have a value that points to the closest geometry. So if we look at this image again, or is it open image, new tab? There we go. So if you can imagine that this is an empty space on top of this. So these are all stacked on top of each other in 3D space, and there's no space between. You can imagine that if we sample the sign distance field at this position, and these are the only three sets of voxels, then we might say, okay, from this position, the closest plane or the closest geometry is actually going to be 1.5 units down. It's going to be down here, right? And that would give you the ability to sample these 4 points. Yeah, I think that would work. Okay, we're gonna have to do a few things. We're gonna have to implement sign distance functions, and then also figure out how to make it work with marching cubes, because you'd have to generate the field, which would be different from generating the topology itself, right? So let's say we do our marching cubes and we generate something that looks like this. Okay, we've got a plane here, but actually this, we can make this into a function of some kind, I think, whereby the field, the closest, sorry, I'm stumbling over my words here. Let's get into this a little bit more before I try to explain stuff that I haven't got full experience in. So let's just try to draw points first. First things first. So we'll just put in a uniform buffer into the vertex shader, I guess. Don't need any of those. Okay, now it's going to be all pointing to default descriptor set, which is not what we want, I think. Yeah, we want to make a new descriptor set. So basically we want another pipeline, set of pipeline variables. No. Okay, so I'm going to select everything in here. Actually, I'm not going to select everything. I will just do it line by line. So we've basically got to rename a lot of these variables because we're using the main pipeline. So the descriptor pool is fine. We can do that. Descriptor set is going to be point cloud descriptor set. That's fine. And the uniform buffer is going to be the point cloud uniform buffer. And it's going to be the size of, let's say, 8 by 8 by 8. That's not a size of. Size of F32 times 8 by 8 by 8. So it's going to be 3D volume of 8 by 8 by 8 points, which we're just going to store as float 32 for now, just to make it a bit easier. We can worry about data compression later. So this is creating the uniform buffer, so need to make sure we prefix this with point cloud. This is going to be the point cloud uniform buffer here. And we're allocating, what are we allocating here? Allocate memory. Yeah, this is for the buffer, right? Okay, uniform buffer memory. No, we need this. We need host visible, host coherent, because we're going to upload this from the CPU. Okay, there is no sunlight uniform buffer, so we can get rid of that. There's no debug storage buffer, we can get rid of that as well. We don't need a sampler, at least not right now, not in this pipeline. And let's see what we got here. We got One uniform buffer, yes. That's this size, that's correct. And all of these are non-existent. So we update the descriptor sets, that's all good. This is the point cloud pipeline. And I'm just going to use I guess I'll just make a new shader set for it called point cloud. And we'll say that there is no vertex buffer. So I'm pretty sure we can actually send in the chunk position on a uniform and then just calculate the world position based on the vertex, the current vertex index and the world position. So we don't actually need to send in vertices, which means we don't need this. And the topology is going to be point list. I don't know if we leave it fill, I guess so. Don't think it really matters. Depth, do we want depth for these? Sure, I'll just leave that on. I don't really want dynamic state. There's so much dynamic state in the render code that I actually just started moving stuff like the viewport and the scissors out of dynamic state because it's a lot to put down there. So if we go down here, we can just add in viewport and scissors, and we get rid of those, and we don't need to change the cull mode or this or any of that. Okay, we can just delete all of this. That's good. Okay, the render target is going to be rendering to a swap chain, and that's a depth buffer. Depth format. Yeah, okay, good. Okay, I think that's all good. Now we need to actually make these variables though. So we need point cloud uniform buffer, point cloud uniform buffer size, point cloud descriptor set, and a point cloud uniform buffer memory. Okay. So let's make those. Descriptor set, we needed one of those. We needed a uniform buffer size, buffer, and memory. That's all good. I think that's it. I'm going to put it at the bottom here. Eventually, we'll come up with some nice abstractions for all the Vulkan code because there is so much of it. There's so much duplication. I mean, this pipeline function has been pretty good, I think. I quite like it. So create a pipeline here. We've got a little bit of config. I've mixed a little bit of Vulkan with a little bit of custom types. So I'm probably going to, I mean, not there. Up here. So some of these are custom types, some of these are Vulkan. Eventually I'm going to phase it all out so it's all custom. And then the whole thing will be wrapped and can just use it forever, regardless of the backend. Although I don't think I'm going to change the backend, but still. Okay. Some things are just easier, you know, easier defaults, like you can make your own type, and then you can assume if you don't pass in configurations to it that there's some sensible defaults. Anyway, so what have we got that's broken? We haven't made these shaders yet. So we need point cloud vert GLSL. So this is going to be a really simple shader that has a uniform buffer. So yeah, binding equals 0, uniform, and I'll just call it density. I don't really think, I never actually use the name. I don't really, I guess this comes up in the debug stuff, so I'll just leave it there. You can also name them like this by adding like some value here. UBO is common, and then you would refer to this field that I'm going to put in here, which is going to be a, I guess it'll be a float array. of 8 by 8 by 8. So that's 512, right? Yeah, I think so. Now, is that the best way to do it, or would it be better to make them vec3s? No, that doesn't make sense. You could do something like this, 3D array, since technically, you know, I mean, not technically, literally we're doing 3D stuff. Yeah, I guess that's fine. I don't really know which one is the best. We want to do main, and we want to say GL position. See, this is where I want to get the index, and also I wanted to send in, rather than just the densities, could also send in a world position. I'm going to call it pos. I can never decide on whether to shorten things or not. Like, should I use pos or should I use something else? So this is the position of the chunk. So I'm going to say it's the, if you're looking at the from the front, this is the front view. So we've got, let's make it 3D, I guess. Going back this way. And then we want to make the axes. So I can't remember what color they usually are. I think Z's usually red, right? Or is X red? So we've got one axis going back this way. Nope. Then one going across here. And one going up. Usually something like this, right? So I'm going to say that the world position is actually this corner. That way we can offset by from here and then start going either back or across and then up, or whichever way. Whereas if you set it to the center, I think it would be pretty annoying, actually. So I'm just going to group these. That's actually kind of useful to have. But yeah. If it was in the middle, then you'd have to, you know, subtract sometimes and then sometimes add and etc. I think this is better. Excuse me. So let's say we do need vertex buffer. I didn't make one. Oh no, we don't. We don't. Okay, I keep getting that wrong because we can just call the draw function with 512 as the number of things we're going to draw, and then it will just work, hopefully. So is GL position the one that we want? I think so. Let's have a look at our simple 3D shader. The vertex one. Simple 3D vertex. Yeah, it is. Okay. I guess we also do need the matrices, view projection. And I guess the model would be the world translation, wouldn't it? So we can actually put this in the push constant. So layout, push constant, uniform. Should I call it S or not? VP, so this is going to be map 4. That's the view projection matrix. And then we've got the model. And if we actually say this is going to be VP times model times, now we need to get the vertex position. So it's something. We're going to have to get it from the ID somehow. So this will be times vertex position 1, I think. That should work. MVP PVM, yeah, that's right. So we need to figure out how to get this. So I think we can use, like we did in our debug was it debug shader here? We used the vertex index here, or GL instance index. That's what it's called now, I guess. Oh, no, vertex index. It was the vertex index. Well, which one do we want to use though? Because the instance index, if we use instance rendering for point clouds, you know what? Let's just do the simplest thing first. This. So this number is going to be 0 to 512, right? So then I guess we need to translate. No, we don't. We just need to say, yeah, how do we get the position from the model as a vec4? Well, we don't have to do that. No, we don't have to do that. That's done here. Okay. So we've got the vertex index. Let's say it's 0. Then that would be position x, y, and z would be 0. So we need to do something like z times, oh, but we don't have the z. What is this type? It's an int. So if we say float, no, we want int. X is going to be vertex index. Okay, we need to figure out which direction we're going to go. So if we were doing this in 2D, I'll just do it in 2D first to make sure we can figure it out simply. Let's say we've got, actually I'll just make this smaller, and I'll just say we've got 2 rows here, just to make it a bit easier, maybe 3. Whoops, 3 rows. And I'll just rotate these. 3 columns, let's just say. So don't worry about those edges there, or maybe I can make these shorter. Why does it have to do that? I'm sure there's a button I could press to make sure it doesn't scale, but anyway. There we go. Just about done. So we've got our little 3x3, and we're going to pretend, probably could have just drawn that more quickly. We're going to start at the bottom left, and we're going to go up, I guess. So we'll say the bottom left is 0, 0. Well, it's really fat 0. There we go, 0, 0. And so therefore the x is 0 and the y is 0. That's fine for the first one. Now for the second one, we're going to have an index of 1. And that means the x is going to be 1. Right? So the x is going to be index. I'll just use an I for index, I guess. It's kind of annoying. I should get my drawing pad, but anyway. Drawing with the mouse sucks. Or writing with the mouse, I should say. Actually, I can just use the text thing. I should just do that. Alright, so we've got 0, 0 for the first one, and then for the second one, we've got 1, 0. And so that's going to be I and 0. But what do these actually mean? Well, the only number we have is I. And so what happens if we, what just happened there? What happens if we, for example, go to the next one? It's going to be 2, 0. That's still I, 0, that's fine. Now when we go to this point here, it's going to be 0, 1. So obviously I is now going to be 4, not 4, 3. So that doesn't work anymore. So we've got to do something like I mod the width. So this would be the width across here. And then that would give us, I mod width would give us 0, I think. Or is it divided by width? I think we do divided by width. 3 divided by 3 is 1. No, we want mod. Yeah. Sorry, I mod 3. And then for the y, we want I divided by 3. I'm pretty sure that's right. But we'll probably want I mod 3. So this is going to be correct, right? But then, and I'll actually just type that out. So I mod 3 is going to be 3. No, 0. And then I divided by 3 is going to be 1, so it's going to be 0, 1. That's correct. And the next one, though, is going to be 1, 1. So this isn't going to work. So we're going to get I mod 3 is going to be... I really should have put what I is here. So I is 0, I is 1, I is 2, I is 3, I is 4. Sorry about the notation, it's quite messy now. So we want to find these positions, and then this is sort of the naive way of doing it. Now we've got 1, 1, which is going to be a problem, because if we do I mod 4, we're going to get... Sorry, if we do I mod 3 again, we're going to get 1. That's actually correct, isn't it? And then I divided by 4 is going to be 1. Oh, this is different though. Yeah, so these are... Now we have to change it again. So that's going to be 1, and that'll probably end up being 1, because 4 divided by 3 is 1 point something. And so the integer division will probably give us 1, but you can kind of see that's going to be incorrect pretty soon. So we want something like... I think it's going to be I mod 3 for the x. Well, I mod width, I should say. And then the y is going to be I divided by height. Is that right? No, we don't use height at all. I should just write it out. I'm pretty sure I know how to do this anyway. It's I mod width plus times... Oh, I'm thinking of the reverse. That's why I'm getting confused. I'm thinking of how to find the xy coordinate. Sorry, how to find the index from the xy coordinate. Okay, this really shouldn't be this hard. What am I doing? Okay, so I need to get the x position from this. So I'm going to say it's mod width, which you already know is 8. So I'm just going to hard code it here. So that should be fine. But the y position, let's say if we were at index, well, it depends which way we're going to go. So if we're going to go across and then back, or if we're going to go back and then up, or if we're going to go this way or that way. So I'm probably going to go x first, and then z, and then y, I suppose. Or maybe I should do x, y, z. Okay, so I feel like I need to prove this in a little mini program first, because I'm having a brain fart here. Row times width plus column. Thanks, Jeff. Row times width plus column. Yeah. So let's see. Oh yeah, that's to find the index, right? But I need the inverse of that, because I'm not finding the index. I want to find the x, y, and z from the index. So to find, let's say, this is 0, 1. Just putting the little numbers in here, 6, 7. So this is going to be the indices that we need to use to find 8. to find the x and y coordinates. So let's get the calculator actually. It'll just make it a bit easier. Wait, does this have mod? 1 mod 1 is 0, okay. 1 mod 2 is 1, okay, good. So if we say index 4, this is going to be position, well, this is not exactly how it works, but let's say index 4, we're going to find this square, so it's going to be 1, 1, right? So we want to do 4 mod 3 is 1, and then 4 divided by 3 is 1.3, and then it's going to get truncated. I think that's right. But to make sure we're correct, I'm going to actually add an extra column, row here. That way, we're not going to get the right result from the wrong equation, because if it's got equal sides, then you can get a different, you can get the same result, or the correct result, but it's only because they had equal sides. So let's do this again. I'll put the calculator here. So if we're going to find, let's say position 7, that's going to be 1, 2, right? So 7 mod 3 is going to give us 1. That's going to be the x coordinate. And then 7 divided by 4 is going to be 1.75. So that's not correct. So is it 7 mod 4 is 3? That's also not correct. 1 0 1 2. What is this? It's got to be the width, right? It's going to have to do with the width. So man, I must have done this a million times. And I just can't think about how to do it. It's really not hard. 7 divided by 3 gives us 2.3. Okay, 8 divided by 3 gives us 2.6. That's correct. Okay, 10 divided by 3 gives us 3.3. Yeah, so it's, you got to divide by the width, not by the height. That makes more sense. 6 divided by 3 is 2, 0, 1, 2. And so, oh yeah, of course, 9 divided by 3 is 3. Okay, yeah, so these, okay, that's really simple. These are all multiples of 3. Okay. Yeah, so that was correct actually. Fantastic. So now for the Z, it's going to be, we're going to add an extra axis here. So I suppose we can do that. I'll just pretend there's a second layer. So this is the next layer. So we're going to say I've got a layer of 2, I suppose. And then this would be something like, I'm going to ungroup this. Yeah. 12, 13, 14, 15. So then it's going to be 16, 17, 18, 19. So it's going to be the width times the height. Something to do with that, I'm guessing. 21, 22, 23. Okay, so if we want to get 19, which is going to be x1, y2, and then z1. So I want to calculate this number. So 19 mod, was it 3? Is 1. That gives us the x. 19 divided by 3 is 6.3, which is incorrect. And then if I mod it by 3, no, that's not right. So that's the wrong, oh, I think I have to do 19 mod 3, no, not mod 3. 19 mod width times height, which is 3 times 4, which is 12, is going to give me 7, and then you divide that by 3. So you got to do, that gives us a little bit of a more complicated equation. So x is just I mod width. That's fine. Hello, Coded Studio, how you doing? Y is going to be I mod width divided by width, I think. And then Z is going to be, well, let's find out. That's the wrong thing. So we need to get 1 from the Z. So it's going to be, I think, yeah, I'm not sure actually. Let's see. I cannot divide by 0. I didn't mean to divide by 0. Okay. I'm trying to type I, which is why it's not working. So I is going to be 19. Can I make the code fonts bigger? Yeah. Is that better? So let's say 19. I think this is going to be, okay, let's cancel everything. 19 mod. I'm going to do width, which is 3 times 4, which is height. So that equals I divided by 12. Yeah, actually you're right. Yeah. So it would be divided. So 19 divided by 3 times 4 is 1.58. Yeah, so on the first layer and about 58% of the way up, I guess you could say that. That makes sense, yeah. So that would mean for example, 23, let's say 23 mod 3 times 4. I should just use 12. Not mod. Why did I use mod again? .9. Yeah, that's right. Yeah, thanks, Jeff. So we want to do, probably use integer divide, not normal divide. Does integer divide work in GLSL? Let's have a look. Zoom in here. So there's division. No, I don't see that operator, Eric. I think that might just be in Python. Or do you mean in the calculator? Okay, so we're going to go across, up, and then back. That's the order. Now, suppose we can say, I wonder if these will automatically convert from ints to floats. I think so, hopefully. Now we need a fragment shader. Oops. We're going to need to set an out variable. So this is actually explicitly set in Vulkan, which is a bit different, I think. Out color. Odin stream. Hey, how you doing? Alright, let's see if we can build the shaders. Taking a break, trying to debug a new shader. Can't figure it out. I know the feeling. Point cloud, but okay, line 12. Let's have a look. Unexpected void. Oh, I forgot the semicolon there. Okay, cool. Now, gonna need to use push constants. We don't even have that set up, but the shaders are here, so that will stop the error messages. So push constants, I don't think I've got, oh I do. Size of 2 mat4s, that's correct actually. Good. This is not the default graphics pipeline, this is the point cloud. Okay. That's apparently not a thing. Yeah, that's right, I didn't make it yet. What stage am I at with my engine? Do I have GUI? No GUI, just some, hang on, let me just run it, one sec. Just some light, shadows, and mesh rendering and stuff. Hey Arctic Flare, how you doing? So yeah, some simple point lights, sunlight, simple mesh rendering. Nothing crazy. I was gonna make a GUI soon. I don't know, sometime soon. Okay, so we need to render this pipeline. Let's just go all the way down to here. IAM GUI? No, I'm not going to use IAM GUI. I'm going to do something else. I don't know what though. So, yeah, that should be fine. Draw, what are we drawing? Point cloud pipeline. So, okay, that's fine. We've got push constants, yes. We don't need any of this stuff. I forgot the second underscore, that's unfortunate. I got nothing against IAM GUI, I just don't want to have to set it up in Odin because it's a C++ library and it's not supported officially. I'm going to do one instance of 512 vertices. That all looks good, I think. I'm sure something is going to be broken, but let's see. Compiles. No, it didn't compile properly. Right? You don't know what Odin is? Is Odin a standalone language? Odin is, yeah, it's like C++ or C or C#. So it's this language that I'm using here, which probably just looks the same as other languages. How did my thing not get built? What's going on here? You've only used HLSL, which you've been told is similar to C. Well, they have an entirely different purposes, but I guess you could say HLSL is a C-like language, which is what some people might say. Doesn't really mean that it's like C, though. It just means the syntax, yeah. Yeah, you got it. Yeah. Oh no, I think that's fine. No? No, I got an error here. What is it? Validation error. Point size is not written to, but pipeline topology is set to point list. So I need to set some kind of value here. Point size. Okay. We can do that. So I guess that would be down here. Did it happen to say what it was in and I didn't read it? Probably. So it's in... might be in the topology part. P create infos, P stages, vertex, point size. Okay, so it's in here. Right. But I don't have it set, okay. What am I using to debug? I'm using, this tool is called the RAD debugger. It's in alpha right now. It's pretty good, I would say. It's probably, I mean, I've been using it for a couple of months now. Right, yeah, okay, so we need something for this shader stage. Shader stages. So we're gonna make shader stage. That's fine. What? Where is it? Why do I have to write point size in the vertex shader? What? Yeah, because it has to know what size the points are, right? So, oh, you do it in here. GL point size, is that right? Huh, I didn't know about that. Let's see if that works. Well, maybe it worked, but I still got a crash. Render pass, validation error. Draw must only be called inside an active render pass. So I must have messed that up. Let's have a look. So I was, where was I? Here? No. No. Right, it was right here. So I bound a pipeline, but I didn't begin the rendering. That's probably the problem. So I need to actually grab this. Maybe not that one. Wait, is that one okay? What is this? Depth buffer, rendering. Oh yeah, I should probably do it up here. Yeah, so I'll just grab this. And I can probably do it as part of this rendering here, I think. Okay, well, no errors. Also, oh, there we go. Interesting. Well, there's a point cloud. It's using interesting. It's got weird positions. So, what did I mess up here? push constants should be fine to use. It's the same as the camera. Not that one, this one. Oh yeah, I didn't set any world positions, so I guess the position is relative to the screen, but that should be... Yeah, alright. Also, there was I mod width divided by width. Which is not the same thing. Okay, I mean that's going to be one problem. Where was it? Where are the point clouds? Okay, they're not coming up anymore. I'm going to stop. Oh, there they are. What? Ooh, okay, it's only visible from certain angles. Am I writing this for a hobby project? No. I'm going to make games with this. It's also fun. So it has become my hobby as well, which is kind of cool. Okay. So densities we're not even using right now, which is fine. We don't care about that yet. It's this vertex position that is totally wrong. So we're multiplying by model, which is actually just the identity matrix, which we probably don't want for this. Let's see. No, that should be fine actually, because it should just render at position 0, but I'll separate them for right now. Let's think. I mean, if I just set this to vertex, what is it? GL vertex index 0, 0. Then we're probably going to get a big line of them, right? But yeah, but the thing I'm not sure about is why they're totally moving offset to my camera direction. Did I mess something up here? Wait, MVP, PV, yeah. Let's see. So this should be, yeah, the fragment shader should be not even care. So the GL position is this. Why is this weird? I'm sending in, I'm not even sending in values. I guess I don't know what value this actually is, the vertex index, but I assume it would just be 0 to 1, right? 0 to 512. Vertex index is always 0. There is no GL vertex index OpenGL. Oh, this is OpenGL. So I want this. This is not what I want. I want Vulkan. Contains the index of the current vertex. This is usually an index into the vertex buffer. Yeah, that's right. But in their case, they're using it for this. Yeah, that's fine. it does what I thought it would do. I mean, I'm using it in the debug shader here, so using it right here. Oh, I'm using the mod operator, which is the what does that actually do? That's reversed modulus. Oh, reserved. So yeah, that should be fine. But in this shader, I'm using mod. Why am I doing that? Okay. X minus y times floor, x divided by y, right? There shouldn't be a difference, but maybe there is. I'm not even using that anymore. Never mind. That shouldn't do anything, but I will change it just in case. Yeah. So you can see as I move the camera up and down, the positions of these points get moved at a much faster rate, sort of up and down. And as I rotate around, it's like the projection matrix is totally wrong. Or something, which is weird. Like what if I render them all at 0, 0, 0, 1? I guess I'm not even going to be able to see them. Make the point size larger. Can we even do 8? Well, oh, there we go. There we go. But same kind of problem, huh? I'm really confused about this. I don't think I ever had this issue. Exactly. Was it something in the setup? Like the pipeline? Hang on a second, I'll just... Where was I? Down here. We've got the point cloud pipeline, we've got a uniform buffer that we're not currently using. That's fine. Create the descriptor sets, allocate the descriptor sets, that's all fine. Okay, make the uniform buffer, yep, that's good. That's all fine. I guess I should just look at the configuration here. So point cloud, point list rather. I don't see any problem with this, although the depth stencil obviously doesn't work. Because I can see it through objects. Viewport dimensions seem fine. Push constant size is 2 matrix 4s, that's fine. So what's the problem? If I look at the debug visualization, where is it? I think it's this one, debug pipeline here. Doing sort of a similar thing, a little bit different. Allocate the memory, blah, blah, blah. That's all good. We're drawing triangle strips instead. What if I just change this to point list and then I change the shader? It's debug. Is it called debug? And then I put out gl underscore point size equals 2. Compile. And, oops, that's not good. What's the problem here? So, the last primitive topology, oh, right, it's because it has dynamic. I think it's got the dynamic topology setting, right? Or the dynamic state. So I gotta go down to CMD set primitive topology, here it is. This one. Or I just delete this. And then delete this. Now you can't change it. That's fine. Polygon mode is line. I guess that's a bit weird. But yeah, look, those work fine, right? So the point clouds, or the point rendering is not the problem. Something about the way I'm sending the data into the shader. Okay, so I'm just setting an MVP as the push constant for this one. What does that look like? Just go back down to here. That's the point cloud, his debug drawing right here. So we got push constants. Oh, it's actually incorrect. Interesting. I'm not sending MVP, but it doesn't matter because the model is always the identity matrix anyway. So multiplying model view by, view projection by model would give you the same result. Huh. Okay. Well, what else is there? So bind the pipeline, that's all the same. I mean, I just copied this code, right? So it should be exactly the same here. Bind the descriptor sets, of which there is one, yeah. Could it be... No, it wouldn't be anything. Wouldn't be this, right? Because we're going to draw... What if we just draw 8? No, that doesn't matter. With one instance. There's got to be something in here. Are these actually being built? Because there might be an error. Successfully built point cloud. Oh no, that's fine. What is going on here? Point cloud pipeline layout. We're pushing. Let's see. Did we set this properly? Yeah, apparently. It's a really annoying problem. I don't know how to debug it, that's why it's annoying. So looking at the color pass for this one, right? What can I look at here? Pipeline state. We've got the vertex shader, we've got the view projection matrix and the model matrix. Okay, so does that look right? I guess we'll just check the other one, which works fine, this debug one. Yeah, it's the same value. That's what I would have expected. So that should be fine. There's no vertices. Width is 1920 by 1080 on the rasterizer. That's all good. Is there any difference here? No. The line width is 2, but that doesn't matter. Fragment shader differences, well, nothing to see here. Doesn't do anything. The frame buffer. The depth state is enabled for this. Maybe I should disable it. Although, actually, The debug buffer also has depth enabled. I just didn't turn it on. I don't know, man. I don't know. What is this one? Drawing index 786,801. That's a lot. Oh yeah, that's the big model. Right. So if I actually just don't do that. Where is it? Here? Yeah. We can just... I guess that's fine. I think that will work. So we don't have the big model in the way. Although it was kind of nice having a reference point. If we change these shaders back. Debug vertex shader. So this is going to be, actually that's fine. We'll just set it in here to be, what was it again? Line list? No, it was triangle strip. Pretty sure. Yeah. Okay. Alright, I gotta go to the bathroom. I'll be right back. Hello. So I was hoping that I would have an epiphany while I was doing my business, but nothing happened. So still more or less in the same position. I can't figure out what's going on here. Is it the viewport? Where did I copy the viewport from? Now that I think about it, let me have a look at it. Point cloud. No, that looks correct. That should be 1. I think that shouldn't have made a difference. Swap chain dimensions, that's all fine. No more options here. Polygon mode, fill, col mode, yeah, that's all fine. None of that should affect the position in the world. This should just be the matrix problem. So the projection matrix. Oh, you know what it is, I think? It's this. Wait a second. No, it's not this, right? Move sun, otherwise... Is that correct? Yeah, that's fine. Perspective matrix looks good. Window width divided by 4. That's not correct. So, I'm updating... This is not good. I'm updating the projection matrix. Although I guess that would still be the same result. You'd still get the same the end result out of this. That's probably fine then. It's still weird though. I'm just going to delete those 4s. No need to do that. I thought that was going to be the problem, but nope. Projection matrix. Alright, so the only places we're setting it the only place we're setting it is here. Wait, what is this? Viewport is... Y is the dimensions height? What? What is that about? That's weird. I haven't been doing that with my other viewports. So if we go up to the point cloud thing again, let's see. Is that the problem? Do I need this? That doesn't seem like it would make sense. That would be an offset, right? Yeah, that doesn't make sense to me. Yeah, it's just going to be off the screen. Why I'm doing that for the main viewport, I don't know. So let me turn that model back on. Where was it? Here. And what if I comment out this line? What happens? Right. Can't see anything. Huh. Hey, was that just falling down? What was that? Oh no, it was just me moving. Okay, this is not good. So this is affecting my stuff further down. So I'm setting the viewport here to swap chain dimensions. But I thought it would just be for this pipeline, but maybe not. Oh no, it doesn't matter because I'm rendering it up here in the. Okay, I'm just gonna do a new begin rendering. I'm gonna do a new thing here. I'm gonna put this stuff here. Do a new full render call here. So we're gonna fill this out. Oops. Use the command buffer and rendering info. So let's make that. Let's see what we need. Type is going to be rendering info. The render area is going to be the swap chain extents, right? Is it an extents? Rect2D, yeah. So swap chain dimensions rather. Layer count is 1. View mask, did I use that ever? I don't think so. Color attachment count is 1, and the color attachment is going to be the current, what is it? Where is it? Oh, it's just color attachment, okay. And the depth attachment is going to be depth attachment. Very good. No stencil, no flags, no view mask. Okay, that's fine. Oh, what's wrong with this? Oh, this is extent 2D, but I needed rect 2D. Oh, okay, fine. So the render area is going to be width equals width, and then oops, damn it. No? What's wrong with this? Oh, it needs extent. Oh, so I could have actually just, god damn it, done this. Cool. Hopefully. Alright. Now. Yeah, thank you. Let's see the errors. Errors are good. So, pipeline barrier 2 cannot be called inside a dynamic rendering instance. This can be fixed by enabling. Yeah. So this is happening when I do what? BK command pipeline barrier 2. I'm not calling that directly. It might be in one of my functions. Let's see. Begin rendering. So it's called within a render pass instance started by command begin rendering. There must be no buffer or image memory barrier specified by this command. Okay. Let's see. So down here I've got another one. Begin rendering. Right. Bind the pipeline and then bind the descriptor sets. I do need to do that actually. Which was a missing step. Oh no, I've done it here. It doesn't really matter in the order, I think. What's the problem here? So, oh, it needs, this end rendering needs to be here, and then we transition the image layout, and then we can, yeah. I'm not going to transition that yet, though. I'm going to actually move this up here. Okay. Well, now the only thing I can see is a red dot sometimes. What the? Oh, hang on. Well, let me just comment this out. Save, and then... Yeah, okay, I got an idea. So we're rendering onto the color attachment. But there's no... what is it called? I need to make sure that I don't delete the stuff in the color buffer when I load it. I'm pretty sure that's a thing. Like this, depth attachment, clear store, color attachment. So I'm using the same color attachment, which means I'm just clearing it again, which is totally wrong. So I need to make a new one. Where were we? Up here somewhere. Here it is. So this can be point cloud color attachment. It's going to be the same color attachment, or the same image view, but we're going to load rather than overriding it. So that means the image won't get overwritten with our new data. It's still not going to fix the problem though, I can tell already. All we've done is add an extra drawing command, but yeah, the problem is the same. That's so bizarre to me. So if I'm looking at position 0, that's position 0 is basically here somewhere. I suppose that makes sense, but it shouldn't go. It shouldn't be offset by that much. I've now moved to the sun's position, and if I look down there, yeah, okay. It's kind of... yeah, weird. I don't know. I've done something really simply stupid. I know it. Okay. I'm gonna ask Claude. Now, Claude might be totally wrong, but let's see. My point cloud is not rendering at the correct position, and when I move the camera, it seems to fly wildly off screen. And I'll just give it this information. I'm just going to do it on the other screen because I use it for a lot of things, including some personal things. Let's see what Claude says. Okay, the vertex index calculation is commented out, so every point is being, yeah, that's fine. Yep. The points need to be properly spaced out. Okay, that's not actually the problem. Properly updating the density, blah, blah, blah. Okay, yeah, it's totally incorrect. Yeah. I don't think this is the problem either. but let's try it. So it says that I'm doing multiplication twice, which is true, but I mean, that's what it looks like. That's what it looks like the problem is. So it suggests that I do something like this. vec4 world position equals model times. Then we just assume that the model, that doesn't make sense. Whatever. So we're just testing at the origin, right? Then this is going to be VP times world position. Okay. Isn't that going to... that's going to be weird, right? Not like this, sorry. Like this. That's supposed to be vec4 though, isn't it? Let's see. Did that work? Okay. Oh, that is a vec4. Yeah, yes. Okay. vec4 times a matrix is vec4. Okay, yeah. Yeah. As I suspected, it did not solve the problem. Man. Yeah, that did not work as I thought. Okay. Yeah, I didn't think it would be much help asking Claude this kind of thing. There's too much code and too much stuff going on. Can't really help with this kind of stuff. It's just giving me suggestions to do exactly what I'm already doing, so it's not really useful. Like, make sure that the command draw command is using 512 vertices. I'm like, yes. Yes, I'm doing that actually. Funny you should say that. Let's see, mvp.view. That's... It's got to be something really stupid. I hate these sessions where there's just some really annoying simple problem. These are matrix 4s, yes. I'm not even using this uniform buffer. I don't understand. What if I just set the position to 0, 0, 0, it's going to be in the middle of my screen all the time, right? Is that right? Let's just test that. Because this is normalized device coordinates, right? So that's middle of my screen all the time. That's correct. So something is happening with this view projection matrix that's making it wrong. So if I look at simple 3D, which is not simple anymore, right? So we're taking the vertex position and multiplying VP and model by vertex position. That's, yeah. That's exactly what this is, right? So the only answer is this is incorrect. This data. That's the only thing I can think. Oops. So we'll double check it again in render doc. Actually, I've got the, oh geez, see, look at that. What is that? That's definitely wrong. So it seems like there's two issues. Maybe not actually. Maybe there's just one issue, and it's something to do with the drawing commands. Alright, so we're not going to use a depth attachment. Yeah, we're just not going to do that. No depth attachment. Let's just make it as simple as possible. Clear value. We're not going to clear anyway. Go back to the pipeline layout here. Get rid of. So yeah, we can just get rid of all this stuff. Wait, where is it? Hang on, I left this in here? Point cloud uniform buffer stuff? That's not good. Did I do it twice? Okay, that's weird. Alright. Oh no, that was fine actually. Anyway, we're gonna have no descriptors. Okay, no descriptors, get rid of this. Go to the vertex shader. Where is it? Just comment this out. Okay, rendering to no depth. That's fine. Dimensions is fine. Viewport. This seems like maybe there's a problem with it, but seems fine. Depth stencil is none. Rasterization fill clockwise pointless. That's fine. Okay. I should build it in a new tab in case there's a problem with the shader. And no, it seems okay. Alright. We got a validation error, that's good. What's the problem? Descriptor sets does not exist? Oh yeah. That makes sense. So we're binding the pipeline, we don't need to update the descriptor sets. Yeah, I suppose that's fine. Same problem. When I'm looking at 0.0, 0, it's in the middle of my screen. But when I look away, it moves around. Okay. I was hoping to have a productive session. Unfortunately, that's not happening. So we've got a drawing color pass here. All right. We'll have a look. We're going to draw on this image. That's fine. That's what it looks like. This one has got depth as well. Basically, I just wanted to look at, where is it? I mean, I've looked at this before. It should be exactly the same. The MVP. So this is the debug pipeline, right? Okay. And this one, it's the same. And this multiplied by this is going to be the same as well. I think. Yeah. That's how it works. So, we don't need a multiplier right now, but that's not going to change anything, right? Yeah. Well, I'm kind of out of ideas now. How to debug this? Is there something about point cloud drawing that I don't know? What if I change it to a different drawing type? Like if we draw, for example, triangle list, but then everything's going to be at 0.0 and we're not even going to be able to see anything because it's all at the same point. We could change the shader. Where is it? To do something like this. And then this. Wait, let's just make sure that builds. Yeah. Oh, okay. Okay, this is a problem with the viewport. It's got to be, right? It's the only thing that's different. But the weird thing is that the other pipelines don't have this issue, so I'm so confused. But I'm going to copy the default pipelines viewport settings. Where is it? So what's different here? The only thing is we've got the dynamic state. Everything else is the same pretty much. So I'm going to get rid of this and the scissor just to be safe. This is the only other thing I can think of testing. So CMD viewport, CMD set viewport. I will just grab this exactly and I'll put it down here. Wait, actually, where was it exactly? After binding the pipeline, that makes sense. These didn't change in between, so I can just delete them. If this is the problem, I don't know what the problem is. I mean, if it is the problem, I don't know, and if it isn't the problem, I also don't know. Okay, that was the problem. Why? Why was that the problem? Shit. The viewport has to have a flipped height because the dimensions in Vulkan are reversed from what I'm used to. I missed that minus sign. God damn it. Told you it was going to be something stupid. So basically, if I just put this back and I put height as negative this, and then y is going to be this, that's all fine. And then this is going to be point list. Hey, would you look at that? We got a bunch of points. I messed up the math, I guess, but that's cool. So the Y position is totally wrong. It's supposed to be something else. Divided by 8 mod 8, right? Oh, well, look at that. So it was a viewport issue. Okay, I need to get on top of this at some point soon. So I want to make it so that I can set my viewports to like just the normal width and height, and then at the end I can do the flip. So that way I don't run into this problem ever again, because that was insane. And also, hang on, if I got this problem here, then what about in my debug UI pipeline? The viewport is upside down. That could explain some things. My sun depth pipeline, the viewport is upside down. My depth visualization is using dynamic. Yeah, that's fine. Probably copied. But what about the debug pipeline? It seems to work. Oh, I did dynamic. Okay. Yeah. So because I did the set viewport, I just reused it again, didn't I? Oh no, this is different. What is this? Depth converter. Oh yeah. So this one is graphics, the normal default pipeline. This one is the depth converter. Oh, I guess. Oh, I see. I guess because it was dynamic in here, but I didn't set it. It's just using the previous setting. Right, so actually I don't need to set it again, I think. If I just get rid of this. Where is it? Oh, it's not even here. What the? Am I crazy? Where did I set this? Just in this one spot. Yeah, and so it's just set from this point on. Okay. Well. Bloody hell. Okay, well, first step's done. That's good. So the second step was, actually I can get my uniform buffer back because I'm going to need that. Yeah, don't need the depth attachment. No, actually I'll keep it. Okay, so that's fine. Okay, now okay, this is where we were, and this needs to be reversed again. Cool. So now we've got a depth attachment back, and we've got a uniform buffer, which I should rename this. This is not point light, this is point cloud. And we're doing 8x8x8 float 32s. Should be able to access them from here, and then I'm going to say, actually we can also access them in the fragment shader, point cloud fragment shader. I'm going to say, okay, I guess if, let's say density first, float density equals, should I just send in the density from the vertex shader? Yeah, maybe I should. Instead of doing this, layout location equals 0, actually is fine. In flat float. Density. If density is less than 0.5, then we're going to color that red, I guess. Actually, we can just do something like this. So to get more red, the more density there is, which should be fine. Now we don't actually have any densities. And we need to also send this to the other shader here. So I'm going to say this is going to be just the density lookup from here. So float density equals, actually I'm going to say out density is equal to densities x, y, z. I guess we'll just store them in that order. And to make this really simple, we've got the uniform buffer here. Just going to do something like this. Point cloud densities. We're going to upload the data from the CPU, and I'm just going to make it random. So this is actually floats, or F32s rather. This is going to be point cloud uniform buffer size, and this is going to be the point cloud uniform buffer. Memory, then we're all good, and then we can just say for x in, actually I'll just do for whatever. Actually, you know, I need the index I in 0. Let's do 512. Data I is going to equal to rand dot range f32. 0. No, I think I can just do float 32. Let's see. Between 0 and 1, yeah. Okay, now we're going to get random densities, and hopefully they will be different colors. Well, they're mostly black. And some of them are invisible. Why did that happen? So it should always be red-ish. Well, maybe we'll make it always at least, actually, yeah, at least green, and then it will transition to different color. So that's not, what does red and green make? Is it purple? No, that's red and blue. How can I not remember this? So the depth buffer is on again. I forgot about that. I should probably make it so we can turn that off, eh? Depth buffer, show depth buffers. No, not that one. This one. Debug depth test enabled. I guess I'll use the same thing, and we'll just copy this down to here. Alright, cool. So we got all green points, which means we have an error. So this is saying the set depth test enable has been called, but since the related dynamic state commands, oh right, it's not a valid state command, not dynamic one anyway. So we need to go back up to here and add it to this list. Where's the dynamic list? Oh, I don't have it. Whoops. And we want dot depth. Is it just called depth? No. Depth test? No, of course not. It's called depth test enable. Okay, great. Okay, that's all good. except it's obviously not working with the densities, which is a bit of a problem here. The density is always 0. So we're setting the out density to be this floating point number. That should be fine, except what is the problem? Was there a shader compilation error? No, there was not. Let's see what the buffer has in it. So if we look here at this one, we should be able to see the pipeline. There should be density is not bound. Did I not bind it? Okay, thank you. Yes, there we go. Okay, yep. Create point buffer. It's not bind uniform buffer, it's bind buffers. Where is it? God damn it, somewhere down here. It's too much code now. Bind vertex buffers, okay. I think it's in the rendering info, isn't it? It's in the rendering info. Is it? Not the attachment. No. Oh, descriptor set. I'm pretty sure it's still in the descriptor set, isn't it? Point cloud uniform buffer is here. We've got one uniform buffer. What's the problem here? Okay, if I look at all the places debug uniform buffer is used, which is definitely working. Yeah, that's right. I'm definitely putting the data in there. Unless I didn't set this variable properly, but there should be an error if that's the case. Point cloud uniform buffer. Host visible, host coherent, that's right. Get buffer memory requirements. Yeah, yep. One descriptor set, layout information. It's binding 0 on the vertex shader. That's correct. Descriptor set layout is used below. Yep. What am I missing? Let me have a look at this again. It just says no resource. So if I look at the, not debug UI, but if I look at EAE, hello Christopher, how you doing? It's not, oh, am I not binding the descriptor sets? Probably. I deleted that, didn't I? Oh no, it's here. I'm binding the descriptor sets. So the pipeline layout bind point, first set 0, it's got one set, this is the sets, and there's no dynamic offset. That seems fine. Bloody hell, mate. Okay. We're so close to the answer. This is set correctly, and of course, otherwise we wouldn't even see that. What about the descriptor sets? Point cloud descriptor set is indeed allocated into here. How is there no memory? I'm mapping it here. Unless this isn't doing anything. Let's go to this point. Line 1938. 1938, okay. So we should get up to this point. Create a data variable, which should not be null. It is null. Oh wait, next line. Okay, it's not null, it's full of floats. And then, if we say this is an array of 512, and it's putting in random values, that's what I would have expected. That's all good. I don't think that would be a problem, but I need to get rid of this. Breakpoint, go away. Yep, thank you. Man, I'm so confused now. Because the problem is, it thinks the buffer is not there. Which means I forgot some important step, but I've used uniform buffer so many times now, I don't know what it would be. No resource. 0 provided for the density value. Like, okay, let's look at the, what's this one, right? The debug drawing buffer. The uniform is correctly here, 2048 bytes. And then even the lighting, the normal mesh has a lighting buffer, uniform buffer, it's here. So what the hell did I forget? Alright, I'm just going to look at every instance of uniform. There's just going to be a lot of them. Okay, uniform buffer size, memory, and buffer itself seems to be the main thing. Pool size. Did I run out of uniform buffers? No, it would have warned me, right? Pretty sure I didn't, but I'll increase this anyway. And we'll just have a quick look. Yeah. So, uniform buffer size, very good. Okay, create the buffer. Wait, did I create the buffer? I'm pretty sure I did. Then allocate the memory. I'm pretty sure I did that too. Then use it in the descriptor set. Did I do that step? Yeah, one uniform buffer for the vertex shader, binding 0. There's nothing else that I need. Wait. Yeah. Okay, allocate memory for the uniform buffer. Hang on a second, that's wrong. Descriptor set is not context descriptor set. It's point cloud. God damn it. I need to make these into a function or something because it's so error prone just having to change the variable names. Did that work though? Yes. You can see them kind of flickering to yellow, but it's kind of weird that they're flickering. Am I updating this every frame? Oh yeah, I am. This is in the loop. Okay, we don't want that. So I'm just going to move this out. Up here somewhere. I guess I'll put it here. So I only want to do that once. Now we should have a bunch of yellow and green points. Oh yeah, I can kind of see the yellow ones. I should choose a different color combination. It's a little bit hard to tell the difference between those. We could just go red to purple, I guess. Or we could do maybe negative 1 minus in density, so it goes from... that doesn't really matter, I guess. Yeah, it's just blue to red. Okay. That's cool. Right. It's a big milestone. I can't believe how much time we wasted on... what even was it? Now I can't remember. It was the viewport. Bloody viewport. God. I really hate when that happens. It should not have been even an issue, you know? Should have just been working. But now some other things are making more sense. Like, for example, if I turn on the... where is it? What's the button? There's a button I had for this. Is it D? No, not that one. P? No. Y? Yeah, there we go. The depth maps you can see here. So I actually had to flip the depth map, the sun's depth map, which is the one on the right, because it was showing up upside down, and now it makes total sense as to why that was happening. Yeah. Damn. Oh well, that's fine. As a side note, I reckon you could make a pretty cool looking renderer just using like a spooky kind of renderer using the depth map on the top left. So everything is really hard to see until you get close. It's like there's tons of fog or something. Could be kind of interesting. Yeah, so what were the other things that we were supposed to be doing? Supposed to getting to like multiple steps. Draw one configuration, so that didn't happen. So I'm gonna have to do that later because I have to go. I want to thank you guys for tuning in, and I will see you next time where we will implement some 3D terrain.